Hey guys, this is Einar. I hope you're doing great today and welcome to this tutorial where we're going to learn how to use confidence intervals to conduct a hypothesis test. And more specifically, we're going to learn how to use confidence intervals to test the difference between two sample means. So what we're going to do is we're going to take the difference between the means in these two samples and create a confidence interval around that and see if the difference we get empirically is larger than the null hypothesis. Now, what does that mean? Well, the null hypothesis basically is that the first sample mean, subtracting the second sample mean, is equal to 0. Now, we get this results if these two sample means are the same size. So, what does that mean? Well, if the two sample means here are the same size, we do actually not have a difference, which in which case would say that our initial hypothesis that there is a difference between the two sample means is wrong. So, we're testing the null hypothesis. Our data set consists of tango dancers, and these are the number of Facebook friends they had before a huge event. Say it's a huge tango festival, and they walk around and dance and socialize and, you know, stuff that happens on tango festivals. So this is before that huge event, and then we measured the number of Facebook friends they have after the event. And you could guess that, well, when they've been socializing and dancing together, they will probably, you know, connect with each other more and have more friends. So the mean number of Facebook friends should be larger in this sample than it should be in this sample. So what we're going to have to do is we're going to have to create a confidence interval around the idea that this is not true. Actually, we're testing a null hypothesis. So this will become 0 as our null hypothesis, which would mean that the sample means are in fact not different from each other. We're going to choose a critical Z value, which means we're using the normal distribution for this in this case. And you can find the critical Z values in a table. It's a two-sided hypothesis test because we have plus and minus here. And then we're going to multiply all of this by the standard error. Now the standard error here is a pooled standard error, which means we're combining the variation in the first sample and in the second sample and using the sample sizes. So it's a combined uncertainty, which means we have to make a number of assumptions, and I encourage you to read up on the literature. I might make a tutorial on it too. But to begin with, for example, we have to assume that we have fairly normally distributed variables and stuff like that. So be careful when you're doing this. Read up on the assumptions that you have to make. So let's start calculating. We're going to need the sample sizes of our two samples. So we're going to start calculate that. About equal to count. I'm going to count the number of tango dancers in my first sample, and this was before the huge tango festival event, so there. I counted, and we find that in the first sample we had 147 tango dancers. In our second sample, which is the sample after the huge tango dance, I go down here, I select all my data, close that, and I find that I have 137 tango dancers in my second sample. So we have this part of the formula, and we have that part of the formula. Now we're going to need the variation around the means in our sample. And in order to get that, we usually calculate the mean first. So we're going to do that. We're going to calculate our estimate first. Average. So the average number of Facebook friends they had before that Tango Dance Festival of Awesomeness was 245 Facebook friends on average. After the dance, the huge festival they had, and this is exciting, well, it's more exciting for you because I know the answer because I created the data, is 375. So you might say, okay, hey, look, there's a difference. They had more Facebook friends after the festival than they had before. Enough said, end of story. That's not true. This would only be true if we had asked all the tango dancers that participated in the festival, but we haven't. We have samples. So we have to take our uncertainty into account. And that's what the standard error is all about. We're going to need. That's why we calculated the sample sizes. That matters. How many people did we ask? And the variation around our means, because that says something about how uncertain we can be about the guesses. How much does it vary? So we're going to calculate that by var, VAR, for the variation for our first sample. Go down, up. I missed it. I'm going to have to do it again. There. I select my entire data set like that, and I get a variation. I'm going to do this for the second sample as well. Var. I go down here, I select my entire data set, there we go, close that, and I get a second variation. So now we have our n's, we have our variations, we have our critical z values, because I looked them up in a table for you, remember, and we have the null hypothesis, which is that this difference here is going to be equal to 0. So we can actually start calculating our our confidence intervals. But to make this easier, we're going to calculate the standard error here in its own area, so to speak. So square roots, see here, square roots. I'm going to take the variation in my first sample, right there, divided by the number of people in my first sample. I'm going to add the variation, you can see it there, the variation in my second sample divided by the number of people in my second sample. So I choose my variation there. Divided by the number of people, close that parentheses. Oops, and I did some kind of mistake here. All right, this is, I'm sorry about that, guys. There. I'll calculate it again so it's clear. The square root of the variation in my first sample divided by the number of people in my first sample plus the variation in my second sample divided by the number of people in my second sample. And there we get our standard error. Now, the difference between these two is our test variable, you could say. It's not really the test variable, but it's the difference that we are going to be comparing to our confidence interval. So I'm going to take x1 here minus x2. You see it there, x1 minus x2, and I get minus 130. Now it's time to stop and think for a second. You might be questioning this because it says minus there, and you can see that this number is larger than this one. So you say, but they had more friends after the dance. Why are we getting minus here? What does that mean? Well, it really doesn't mean anything right now because we're doing a two-sided test. Because we're testing around a confidence interval with a positive side and a negative side. So we're just looking at the absolute difference, in absolute terms. We're not saying in which direction it's going. I might as well do this. I could do this and get 130. So it really doesn't matter if you have minus or plus there for now. So bear that in mind. And we're actually ready to start calculating our confidence intervals, which we're going to be comparing to this distance here. So H0, my null hypothesis, is that that's a center point, 0. There's no difference between the samples. And the lower limit on the confidence interval around that idea is my difference, which is this part of the formula, minus, because we're working with the lower limit, our critical z value, multiplied by the standard error, which I have there. And I get my lower limit of minus 128. The upper limit, meanwhile, is going to be 0, which is this part of the formula, plus a critical z value, and this is at 99% confidence level, just so you know, okay? Multiplied by the standard error, and I get my upper limit, which is 128. Now what I do now is, I take a look at this difference here, 130 in absolute terms. Is that within our interval? No, it is not. It is larger than 128. And in illustrative terms, this is what's happening here. We have a confidence interval. This is done for 95% confidence level, but it's the same principle. We have a confidence interval here. We have our critical z values, and in this case it's 2.57. So 2.57, somewhere around there. We've translated this into number of Facebook friends, so it's going to be minus 128 there and plus 128 there. And we're comparing that to the real difference that we found between our samples. So we can find that that is located in our tails, right? So our sample difference is located in our tails. And what does that mean? Well, when we have a confidence level, what we're saying is that if I conducted this sample 100 times, in 99 of these cases, I would get a mean that varied randomly between these two values. Now, that's not what I'm getting. I'm getting a larger, different mean outside of this interval. That could either be because of the freak chance, which is 1 out of 100, that I'm just unlucky and I'm getting an extreme sample that is outside of our interval. Or it could mean that a real change has occurred. And that's what we mean by statistical significance. We're saying that the chance is very, very low that this change is just due to randomness. So we're saying that a statistical change has actually occurred. Now we're going to do this for a 95% confidence level too, just to practice. So same null hypothesis. I select my distance, which is this part of the formula, minus, because I'm working with the lower limit, my critical value, which is changed because I changed my confidence level, multiplied by the standard error, which is there. So I choose my standard, I choose my standard error there, and I get a lower limit. Same thing for the upper limit, but this time I'm working in the upper limit, so it's plus my critical z value, multiplied by the standard error, and I get my upper limit. And, you know, it's still a significant change, statistically significant. So our null hypothesis is refuted in both cases, and basically that's how you can use confidence intervals to test a hypothesis. And it's closely related to the stuff that we're going to be doing in the future tutorials. So consider this tutorial when we're working on the future ones, and you'll understand the principles behind the scenes, so to speak, when we're working. So have some fun with this, try changing the values and checking what happens. I hope you have a really great day, and good luck with this stuff, guys. Bye-bye.